Hello, myself Purnima, Professor in ANC Department, SVC Bangalore. In the last lecture, we have discussed how the embedded system is defined and what are the various functional blocks of these embedded systems. Moving on to the next topic, that is the embedded system main core. It may be with the microprocessor or the microcontroller. In this class, let us try to understand if a typical embedded system which is designed with the microprocessor, how the embedded system looks like, and how an embedded system with the microcontroller. What is the main difference between an embedded system made with microprocessor as core and microcontroller as core? So to start with, let me take the core of the embedded system as the microprocessor. When you look at the microprocessor based embedded system, it will have a central processing unit. Then the central processing unit is a single chip IC which is available in the form of single chip. This central processing unit, it is able to perform the arithmetic operations as well as the logical operations. Arithmetic and logical operations. This is the block which is held responsible to perform these. Whenever the microprocessor based embedded system in which the CPU it is used, this CPU it is a single chip IC which consists of only the arithmetic and logical unit, along with that the control unit and the working registers. That is the central processing unit that you can look at when you go for an embedded system. It is made with microprocessor. Suppose this microprocessor, if it is used in an embedded system, already we know that the embedded system requires the external peripherals. The peripheral devices, which includes memories, ports, timers, then serial ports, integrated special circuits, then communication interfaces. How these communication interfaces or the memories which are going to be interfaced to the typical embedded system, you can look at this block diagram. If the central processing unit, if it is used, which is a microprocessor, definitely the microprocessor based CPU, when it is converted into an embedded system, it requires the external memories. The memories includes the RAM and the ROM. One is the non-volatile memory and the other one is the non-volatile memory. When you go for the communication ports, input ports, output ports, through which the input devices and the output devices we will be connecting to an embedded system, and the timers for the timing purpose, and the communication interfaces. If you look at these communication interfaces which are associated with the CPU are the serial ports as well as the parallel ports. All these external devices in the microprocessor, they are connected through the two buses. One is the data bus and the other one is the address bus. Depending on how many bits CPU we are going to consider the data bus width and the address bus width, which is going to vary. The capacity of the memory that will decide how many address lines which will be there in the address bus that is connected to the CPU. Similarly, when the data, when it is to be stored or retrieved, how many bits processor or the CPU we are using, based on that the data bus width which is going to vary. You mean to say, it means to say that suppose if you go for the the CPU is of 8 bits, so then the data bus will be of 8 bits bus, And if the CPU is of 16 bits, then definitely the data bus will be of 16 bit. Then if the processor is of 32 bit bus, definitely the data bus will be of 32 bit. Suppose if the memory it is of the 250, for example, in simple words, if we take the 1 megabytes of memory, it is available for externally, which is connected to the CPU, then how many number of address lines we need? Those address lines we will be computing through the n equation, that is the number of memory locations equal to 2 to the power of n. If you are finding the n approximately, you will get 20 address lines. So that is how the number of address lines and the data lines which are concatenated with to form the address bus, data bus, which are being designed. So now if you look at here the microprocessor based embedded system, in simple, it will have a separate central processing unit which is able to perform arithmetic as well as the logical operations. And these arithmetic and logical operations, when they are done, or those operations when the CPU is performing, there will be predefined instructions. Based on those predefined instructions which are developed by manufacturer, according to that this CPU will perform the arithmetic and logical operations. This CPU internally, it consists of, what are the various blocks? It consists of the arithmetic logical unit, which is held responsible for the arithmetic and logical operations. If you look at the other blocks, entire embedded system, it should be under the control of the CPU. So therefore there is an control block, that control unit. And if you check the other component which is existing in the CPU, it is the register set. So temporary storage registers during the execution of any of the program or any of the task or any of the work by the embedded systems. So hence these registers are also termed to be the working registers. This when you look at the closely, when you monitor this embedded system closely, the CPU is a independent unit and it depends on the memories, timers, interrupt controllers for the complete functioning. So hence the microprocessor unit is a dependent unit. And this microprocessor, the way back in 1970s, it was developed by Intel Corporation. The very first IC which was developed is 4004, that is from a 4-bit processor from Intel. And the other embedded system core, as we have already seen from the block diagram, it can be of the microcontroller also. The main microcontroller, if you look, if the microcontroller is placed in this embedded system, the microprocessor in which the CPU was on a single chip, whereas in the microcontroller, the single chip consists of the CPU, the memory, which includes RAM, ROM, the peripheral ports or IO ports, input ports, output ports, timers, serial ports. All these will be on a single chip. So the single chip will be associated with all these the external blocks which we have seen with the embedded system if it is made with microprocessor. So now let us look into this microcontroller based embedded systems, how it looks like. A highly integrated silicon chip. It consists of CPU, a scratch pad, that is of RAM, a special purpose RAM, special and general purpose registers array, Then on chip ROM you can see, or the flash memory sometimes you can see, for the storage of program. This is for program storage, and this will be used for the data storage. Now apart from this, the other block of an embedded system includes the storage, the timer, interrupt controller, and the dedicated I/O ports. So these microcontrollers, since it has all the peripheral components on a single chip, it is considered as a superset of your microprocessor. Which are the general purpose microcontrollers which are available in the market? You can see 8051, it is an 8-bit microcontroller designed for generic applications and domains. It can be used for almost all general purpose applications. So, or sometimes whenever we have to go for the same microcontroller to perform a specific task like automotive AVR, then we can design those applications using the microcontrollers. Since a microcontroller, why this particular microcontroller in a specific application we are using? Because it has all the necessary functional blocks for independent working and found greater place in the embedded domain in place of microprocessors. Even though a limited memory of RAM and ROM, limited I/O ports, timers and serial ports, but depending on which specific application has to be performed, based on that this microcontroller will be very useful. So the microcontrollers are cheap as well as the cost effective and readily available in the market. The Texas Instruments TMS 1000 is considered as the world's first microcontroller. That is what the microcontroller has been, that is where the microcontroller came into existence and its thought came into existence. Now let us see the main difference between after discussing the microprocessor based embedded system and microcontroller based embedded system. What is the main difference you will come across between the microprocessor and microcontroller? Let us consolidate. If you look at the microprocessor, it has only the CPU, which can able to perform arithmetic as well as the logical operations. Here, coming on to the other side, the microcontroller is a single chip that contains not only CPU, it has the scratch pad RAM, ROM, special purpose register arrays, then flash memory on a single chip. Along with that, you can see the timers, you can see the interrupt controllers as well as the I/O ports. So that is basically this difference we have derived from the block diagram. The next difference between the microprocessor and microcontroller, if you look at the microcontroller is a dependent unit, because the microprocessor can't work independently without the help of the external peripheral devices like timers, memory chips, interrupt controllers for their functionality. If any task is given with an microcontroller based embedded system, it is, since it contains all the internal required blocks on a single chip, so therefore it is a self-contained unit. It does not require any external interrupt or timer, UART, etc. for its functioning. The next difference, if you look at between the microprocessor and microcontroller, most of the time general purpose in design and operation. Whenever any general operations have to be done, so during that time these microprocessor based core based embedded systems can be used. The microcontroller, when we are looking, it is mainly designed for application specific. The microprocessor, it does not have built-in IO ports. So whenever IO ports have to be connected to the microprocessor, during that time we have to depend on external programmable peripheral interface. So that is in the market there is an IC which is available directly to support the IO ports for the microprocessor based embedded system. It is 8255. It is also termed to be the programmable peripheral interface device. If the other side you look, the microcontroller, most of the processors contains the built-in IO ports. You need not to worry about external interface and can be operated as a single 8-bit or 32-bit or 16-bit port or individual port pins. Sometimes we can combine multiple ports and sometimes we can independently use these ports. Now, if you look at the next difference between the microprocessor and the microcontroller, targeted for high-end market where performance is important. Here, targeted for the embedded market where performance is not so critical, at present this demarcation is invalid. So right now, if you look at the microcontroller, where microcontroller also it is required with an performance, higher performance. So therefore, this statement earlier it was okay, but now it is overruled. So now, if you look at the last difference of the microprocessor and microcontroller, limited power saving options are not available, so limited number of power saving options. Whereas if you look at the